Hello again, this is Joe Kuttner, the author of Deploying with JRuby from the Pragmatic Bookshelf. One of the technologies covered in my book is TorqueBox, a Ruby application server that runs on the JVM. In this video, I'll be demonstrating how to use high availability scheduled jobs, which are a part of TorqueBox's built-in support for clustering. I'm going to begin in the bottom terminal, where I have a very simple Ruby application. It's so simple, in fact, that it doesn't even have a web component. Instead, it contains a single TorqueBox job called myJob. The only requirement for being a TorqueBox job is that it implement the run method. The second file in the application is a TorqueBox configuration file called torquebox.rb. It tells TorqueBox the schedule we want our job to run on, sort of like cron tab. In this example, we'll run our job every 1 second. Now we can return to our terminal where we're going to start a TorqueBox cluster. We'll do this by running 2 TorqueBox servers on the same machine, which you would not ordinarily do, but it will simulate a cluster for us. In the first terminal window, we'll run the TorqueBox run command with the clustered flag. This tells the server to initialize the components that allow it to communicate with other servers. Once the first server is up and running, we'll switch to the second terminal window and start the other node in our cluster. But this time, we'll have to set an environment variable so that the second server does not conflict with the first server. The 3 properties here will give the second server a distinct name, its own temporary directory, and a unique set of ports that it can bind to. Once this environment variable is set, we can execute the TorqueBox run command again. The second server will start up just as the first server did. But once it's initialized, we'll see a message in both consoles that lets us know the 2 servers are connected. Now we can return to the bottom terminal where we'll deploy our application to both servers with the TorqueBox deploy command. We'll see the application initialize in both servers, and after it's done, we'll start to see the output from our scheduled job every 1 second. Now, what if these jobs were posting this message to Twitter or IRC instead of the console? We'd end up posting our message twice per second instead of once. Maybe we just want our job to run on one server instead of both. Let's shut down our application by running the TorqueBox undeploy command and fix this problem. We'll open our configuration file again, where we'll set the singleton attribute of our job to true. This will tell TorqueBox to only instantiate 1 instance of the job per cluster. Now we can return to our terminal and deploy the application again. We'll see it initialize as we did before, but this time only one of the nodes will start running the scheduled job. We'll also see that the same node has identified itself as the HA singleton master. Being able to run this job on only one node is cool, but the real power of TorqueBox and a TorqueBox cluster comes from its ability to fail over this job to another node. We can demonstrate this by killing the master node with Control-C. Soon after, we'll see that the job starts up on the slave node. This is what makes it highly available. These kind of jobs are just the tip of the iceberg of what TorqueBox provides as clustering features. In my book, I give a more practical example of these jobs. I also show how to use other clustering features such as distributed caching, distributed messaging, and session replication, all of which are built into TorqueBox and don't require any other tools or processes. Thanks for watching.